Hello, everyone. With its advantages such as immutability, traceability, value transfer, and smart contracts, blockchain technology has attracted widespread global attention. Today, we will study a very important module in the course Fundamentals of FinTech, related concepts of blockchain finance. In daily life, have you ever imagined such a scenario? When you need to remit money to a friend overseas, you must go through multiple intermediaries such as banks and payment platforms, often taking 2 to 3 days for the funds to arrive, while also paying high service fees. Is this traditional financial model, which relies on third-party trust mechanisms, really efficient and secure? The emergence of blockchain technology is profoundly changing these rules. This is precisely the focus of today's lesson. Specifically, we will discuss the following 3 aspects. The first, concept of blockchain technology. Second, characteristics of blockchain. Third, core technologies of blockchain. First, let's look at the concept of blockchain technology. Blockchain is essentially a decentralized distributed ledger database. It organizes data blocks in chronological order and links them sequentially into a chain-like data structure, while using cryptographic methods to ensure that the data cannot be tampered with or forged. From this definition, we can identify 2 key points: decentralization and distributed ledger. These are precisely the core characteristics of blockchain. So, how can we better understand this definition? We can start from the pain points of traditional financial transactions. Under the existing financial system, all transactions must rely on centralized institutions such as banks and clearing houses as guarantors. For example, in cross-border payment processes, information verification and data synchronization require coordination among multiple institutions, resulting in low efficiency and high costs. More seriously, once the servers of a central institution are attacked or its data is tampered with, systemic risks may arise. So, how does blockchain technology break this deadlock? Through decentralized and distributed storage, blockchain allows transaction data to be jointly maintained by all network participants, enabling trust transfer without the involvement of third parties. For example, suppose you are making a cross-border online purchase. The buyer is in China and the seller is in Brazil. The payment process needs to go through as many as 4 institutions, including banks in both countries, card organizations, and foreign exchange settlement agencies, potentially taking up to 3 days and incurring high fees. Moreover, if the system of any party goes down or records are tampered with, the payment may even vanish into thin air. This traditional multi-layered centralization model indeed suffers from high costs, low efficiency, and concentrated risks. The global ledger without intermediaries proposed by blockchain is designed precisely to address these pain points. Next, let's take a closer look at the 6 major characteristics of blockchain. Decentralization. The ledger is jointly maintained by all network nodes with no single point of control. Even if any node fails, the system can still operate, significantly reducing the risk of single-point failure. Global circulation. Data is broadcast over the public internet and usually confirmed within about 10 minutes, enabling cross-border, cross-time zone, and cross-currency operations with 24/7 uninterrupted availability. Immutability. Blocks are linked end-to-end through hash pointers. To alter any transaction, one would have to recalculate the hash values of all subsequent blocks and control more than 51% of the network's computing power, which is extremely costly, making historical records virtually permanently trustworthy. Anonymity. Users interact using randomly generated public key addresses without real name registration, protecting commercial privacy while reducing the risk of identity leakage. Transparency. All transactions are synchronized across the entire network in chronological order, allowing anyone to view and verify them in real time, eliminating black box operations and enhancing market credibility. Autonomy. Rules are written into code in the form of smart contracts, which execute automatically once trigger conditions are met, reducing human intervention and lowering operating costs and moral hazards. These 6 characteristics work together. Decentralization and global circulation break down geographical barriers. Immutability and transparency ensure data credibility. Anonymity and autonomy achieve automated governance while protecting privacy. After mastering the 6 major characteristics of blockchain, a natural question arises: which underlying technologies turn these ideas into a functioning system? The following 4 technological pillars provide the answer. Let's still take cross-border remittance as an example. In modern banking systems, banks in both locations must repeatedly verify identities, balances, and exchange rates. If the database of any party is tampered with, funds may be lost. For blockchain to replace banks' central ledger, in such an environment, it must solve 4 key challenges: who records the ledger, how to prevent forgery, how to ensure confidentiality, and how to verify identities. Decentralized technology. Traditional databases are stored on a single server, whereas blockchain synchronizes the complete ledger across thousands of nodes. The system does not rely on a specific center, making single-point failures no longer fatal. Consensus mechanisms. All nodes have equal status. Taking proof of work as an example, nodes compete for the right to record transactions by computing hash values. The node that first solves the puzzle packages the new block and receives a reward, while other nodes verify and synchronize the block, ensuring that the entire network reaches a single consensus on the ledger state. Information encryption technology. Before being broadcast, transaction content is processed by hash functions to generate fixed-length digests, and digital signatures are used to lock in the sender's identity. Without authorization, the original content cannot be restored, nor can signatures be forged, balancing transparency with tamper resistance. Public-private key generation. Each user holds a pair of cryptographic keys. The private key is kept solely by the user and is used to sign transactions. The public key is visible across the network and is used to verify signatures and generate pseudonymous addresses. The public key can be shared openly without revealing identity, while loss of the private key makes assets irretrievable, achieving anonymous yet secure ownership management. Finally, let's examine a case to intuitively understand the application value of blockchain. Suppose a multinational company needs to pay for goods to a European supplier. Under the traditional model, application initiation, bank review, SWIFT clearing, receiving bank confirmation. Funds arrive in 2 to 3 days, with service fees possibly as high as 3% to 5%. Under a blockchain-based solution, buyers and sellers agree on payment conditions through smart contracts. Transaction information is verified by nodes and written into blocks in real time. Settlement can be completed within 10 minutes, and costs can be reduced by about 70%. In this scenario, blockchain achieves efficiency improvement, eliminating intermediaries and enabling 24/7 real-time settlement. Transparency enhancement. Transaction records are accessible across the network, reducing fraud and disputes. Automatic execution of smart contracts. Payments are triggered automatically once conditions are met, without manual intervention, lowering operational risks. In this lesson, we have learned together about the concept, characteristics, and core technologies of blockchain. Through this study, we can see that blockchain is not merely a technological revolution, but also an evolution of social collaboration models. In the financial sector, it has already given rise to numerous innovative applications such as digital currencies, supply chain finance, and securities settlement. I hope that this lesson will serve as a starting point for you to continue paying attention to the integration and innovation of blockchain and financial technology.